All right, so we're going to solve this by taking square roots. This is going to be a new method for solving quadratic equations, which is what we're going to be getting into this unit. So in number 1 here, I have 4x squared plus 1 is equal to 325. So what I want to do, or my goal here, is to mainly try to get this x squared by itself. So we want to try to solve for x squared first, and then we're going to solve by taking a square root after that. So kind of like, let's say if it was instead 4x plus 1 equals 325, and we're solving for x, the first thing I'm going to want to do is I'm going to want to subtract 1 from each side. So I go ahead and I do that, and I get 4x squared is equal to 324. And then lastly, what I want to do next is go ahead and divide by 4 on each side, and then those 4s are going to cancel each other out. So I will get x squared is equal to 81. All right, so this is the point that we want to try to get to on each one of these square root equations. Okay, so numbers 1 through 6, which we're going to do, are going to kind of be set up like this. Once we get there, this is where we're going to solve this by now taking a square root, because the opposite of a square is a square root. And so to do that, I am going to square root both sides of my equation now. And by doing that, my square and my square root are going to cancel each other out, and that's just going to leave me with x. And then once I square root 81, 81, as we may know, is a perfect square, which gives us 9. So x will be equal to 9. Now, this only gives us one solution. We know that because 9 times 9 equals 81. But if we also think about it, negative 9 times negative 9 will also give us an answer of 81. So whenever we take square roots, we're always going to have a positive answer, and we're also going to have a negative answer. So we can write this as 9 and negative 9. That would be our two answers right there. You may also see it as plus or minus 9. And again, the reason why we get two answers here is because, for example, 9 times 9 will give us 81, which is the same thing as 9 squared. And then negative 9 times negative 9 will also give us 81. So we always want to have both the positive and the negative answers written down. And just right here as a note, when taking a square root, we will always have a positive and a negative solution. All right. The only exception we can have to that would be for 0. So I can say here, except for 0. And then also imaginary numbers, which we'll get into later on in this unit. All right, but we don't have to worry about that for now. So for today, just have to remember, when we take a square root, we're always going to have a positive and a negative solution. All right, so I'm going to do the same thing now on number 3. My goal this time now is going to be to get b squared by itself. So to get b squared by itself again, I'm going to want to subtract 5 from both sides first. So that will give me 6b squared is equal to 150. And then I'm going to divide now both sides by 6. So then b squared is going to equal 25. And then again, like the last one, now I'm going to take the square root of each side, the b squared and the squared and the square root are going to cancel each other out, leaving me with just with b. And then the square root of 25, 25 is a perfect square, is going to leave us with 5. So we're going to get 5 and -5, because again, we'll have both the positive and a negative solution. Or again, you can also write it as b equals plus or minus 5. All right, so these two examples were ones where we get a whole number and a perfect square, and it's all really nice. Next, we're going to look at 5 and 6, where that might not necessarily be the case. So we're going to still start out the same way because the question's set up the same. We have 100m squared plus 9 is equal to 45. First step here, subtract my 9 from both sides. I get 100m squared is equal to 36. And then my next step would be to divide by 100 on both sides. And if I divide by 100 on both sides, that will give me m squared is now equal to 36 over 100. Now, if I divide 36 by 100, that's going to give me a decimal. So what I'm going to want to do actually is just leave this as a fraction of 36 divided by 100. And if we look at these numbers here, we might notice something on our next step. So again, like the previous two questions, I'm going to square root both sides. When I square root both sides, I will get m is equal to, again, we'll have our plus or minus, but now we might be thinking about how do I square root a fraction here? And if I notice with 36 and 100 is that they are both perfect squares. So I can actually kind of think of this as the square root of 36 divided by the square root of 100, because we can simply break down each one of those. So I'm going to get a plus or a minus of the square root of 36, which is 6, divided by the square root of 100, which is 10. So m is going to be equal to plus or minus 6 over 10. And we can even take this one a step further, because 6 divided by 10 can simplify down even more after that, because I can divide each one of these by 2. So this is actually equal to plus or minus, if I divide 6 by 2, that will give me 3. 10 by 2, 5. So my final answer here would be plus or minus 3 over 5. So that's a case where we don't necessarily get a whole number there, like the first two examples, but we get a fraction, which we can still simplify down using our perfect squares. Next up, we have number 6. So I have 4n squared minus 1 equals 179. Going to isolate my n squared. So I will get a 1 added on each side. I will get 4n squared is equal to 180. Divide both sides here by 4. And then I'll get n squared is equal to 45. Go ahead now to get n by itself. I'm going to square root both sides. Square and square root will cancel each other out. And I will get n is equal to the square root of 45. Now, the square root of 45 is not a perfect square, nor is it a fraction like I had last time, but we can simplify this radical like we did yesterday by seeing what perfect square I can divide this by. So the greatest perfect square I can divide 45 by, if I go down my list, I check 1, 4, 9, 25, 16, all those numbers there. The greatest one that I can divide by is going to be 9. So I can split this up thinking about this as the square root of 9. And then if I divide 45 by 9, that would be 5. So the square root of 9 times the square root of 5. And then I break that down. It's going to be 3 square root 5. So n is going to be equal to 3 times the square root of 5. And again, just like all previous answers, when I take a square root, I'm going to have a plus, and I'm also going to have a minus. So my answer would be n is equal to 3 plus or minus, n is equal to plus or minus 3 square root 5. All right. So as we see in all of these questions, numbers 1, 3, 5, and 6, we have some number times some variable squared, plus or minus another number is equal to some number. So these are all set up pretty much exactly the same, and we solve these using basically the same steps, and then sometimes the simplifying works a little bit differently. Now, if I look at the bottom section here, these ones are set up a little bit differently because now we have y is equal to something inside parentheses. And this is how we would solve it if it's given to us in vertex form. And we know vertex form from previously in the unit. So we'll start with y is equal to x minus 2 squared minus 1. How I start this is where this y equal is, I'm going to actually change this to be a 0. Because I'm going to set this equal to 0, and then it's going to be equal to x minus 2 squared, so I'm just rewriting what we have, minus 1. So 0 is equal to x minus 2 squared minus 1. And then I'm trying to go ahead and solve for x. So the first number that I want to move is I want to move the thing furthest away from my squared. And that's going to be that number outside the parentheses, which in this case is going to be 1. So I'm going to add 1 to both sides, and I will get 1 is now equal to x minus 2 in parentheses squared. Now our next thought might be to go ahead and move the minus 2, to get the x by itself, x squared by itself, and solve like the last question. However, if we remember about our order of operations, we can't move what's inside our parentheses here. So in order to cancel out that squared, which is around the parentheses, I'm actually now going to go ahead and square root everything on that right side. So when I do that this time, now this squared is going to cancel out with our square root. And then I am just going to be left with, on my right side of my equation, x minus 2. Now, I just took a square root, so now I take the square root of 1. The square root of 1 is 1, but just like in the previous questions that we did, when we take a square root, we're going to have to make sure we have a plus and a minus answer. So 1 plus or minus 1 is going to equal x minus 2. And so now we're going to set this up into two equations, one with our plus and one with our minus. So I'm going to do that over here. So I'll have two different equations again. So let's do negative 1 is equal to x minus 2. And on the other hand, I will have a positive 1 is equal to x minus 2. Again, we're splitting this up because, again, another way I can think about this is just having it as negative 1 equals x minus 2 and positive 1 equals x minus 2. And then I'm just going to now solve each one of these separate equations for x by adding 2 on each side for each of them. So on the first one, negative 1 plus 2 will give me 1 is equal to x. And on the right side, I can add 2 again. So then I'll have 3 is equal to x. So my two solutions, which I'm going to get here, are going to be x is equal to 1, and x is also going to be equal to 3. So those are going to be two solutions again. And that comes from the fact that when I square root earlier in the equation, I'm going to get a positive and a negative answer. We're going to do this again one more time, for example, in number 8. So I'm going to subtract 4. Actually, hold up. I'm going to set this equal to 0 first. So 0 is equal to negative parenthesis x minus 1 squared plus 4. And then, like my last one, I'm going to subtract the number outside the parentheses, or add the number depending on what it is, on both sides. This time it's going to be subtraction. So I'll have negative 4 is equal to negative parenthesis x minus 1 squared. Now, this question compared to the last one, we have a negative in the front. And to get rid of that negative, I'm going to go ahead and divide by both sides with a -1. And so -4 divided by -1 and negative divided by negative is going to give me a positive. So now that will give me 4 is equal to x minus 1 squared. And then again, that negative and negative are going to cancel each other out. So then I square root both sides to get rid of my square root over my parentheses. So then I'll get x minus 1 is going to be equal to the square root of 4, which is 2. But just like those last two, or last however many questions we've done, it's going to be a plus or minus 2. So now, like the last question, I'm going to set this up into two different equations. I'm going to have -2 is equal to x minus 1, and I'll have a positive 2 is equal to x minus 1. And I'm going to now add 1 on both sides for the first equation and add 1 on both sides for the second equation. So I'll get -2 plus 1, which is a -1, is equal to x. And then 2 plus 1 is 3, is equal to x. So my two solutions for number 8 here is going to be x is equal to -1 and x is equal to a positive 3. All right, I would like for you guys to go ahead and finish up the rest of that page. And then once you're done with that, go ahead and work on Delta Math.